Okay, I want to talk about calculating limiting reactants. So this is what stoichiometry really boils down to, and this is one of the hardest questions you're going to come across in stoichiometry once you get past the vocab. So it's all limiting reactant problems are when you have grams of one reactant or grams and moles of a second reactant. If you have two values for your reactants, if you have two values, then you have a limiting reactant problem. If you have a number for one reactant and the other reactant is in excess, so if this wasn't 100 grams, but if it said it was excess P4, then this problem becomes a lot easier. But unfortunately, we have two values, so we have to deal with both of those values, and I'm going to show you exactly how. So whenever you're doing this type of problem, you need to have your stoichiometry steps with you, okay? And what I mean is these 4 steps that we wrote down on the board, you've got to have these with you in your notes, okay? So step 1, balance the equation. Step 2 is to convert grams of reactant to moles of reactants. Okay, to do this, use the molar mass of the reactants. Step 3 is to convert moles of reactant to moles of product. Okay, and then to do that, we use the mole ratio and coefficients of the balanced equation. Okay, remember these guys up here, these are your coefficients. So in this problem here, it's already balanced for you, so we can skip step 1 and move right on to step 2. In case of a limiting reactant problem, you actually don't have to do step 4 either. They don't specify that you're looking for moles or grams of product, so we can skip a step and just leave it as moles of reactant to moles of product. Okay, so we don't actually have to do step 4. So what we're going to do in this one is we're going to do step 2. We're going to have to convert from grams of reactants to moles of reactant, and then we're going to have to convert from moles of reactant to moles of product. Whichever one of these two values results in less product is our limiting reactant. Okay? Whichever one of these two values, 100 grams of FS8 or 100 grams of P4, whichever one results in less product is our limiting reactant. Okay, so let's go ahead and get started. We'll use 100 grams of S8 first. So we'll come over here. 100 grams of S8 will be our starting point. So we'll create our little grid. Now, we have grams of S8, so we want to get to moles of reactant, our reactant being the S8. So we go have grams of S8. We want moles of S8. Okay, notice here we're only changing one thing at a time. So we're keeping S8 constant. We're changing from grams to moles. Okay, so grams of S8 can cancel out. It just so happens that the molar mass of S8, remember molar mass comes from your periodic table. So if we look at sulfur, it's 32.066. So we'll round it to 32. And then there's 8 of them in this compound, so we have to multiply 32 times 8. When we do that, we get 256 grams per 1 mole. Okay, so that takes care of step 2. We're going to go ahead and close that off and open up step 3. Step 3, we want to go from moles of reactant to moles of product. Okay, so we have moles of S8. We want to go to moles of our product, which is P4S3. Okay, notice here we've kept moles constant. We've changed from reactant S8 to product P4S3. Okay, we have to use our mole ratio here. Okay, and it says mole ratio are the coefficients of the balanced equation. So our coefficient for S8 up here is 3. And our coefficient for P4S3 up here is 8. Okay, so when we do that, we plug this into our calculator. we're going to plug in 100 times 8, okay, and that's what's up top, and we're going to divide that by our 256 times 3. Notice I've got the parentheses, so we're keeping the 256 times 3 all together and the 100 times 8 all together. When we do that, we get 1.04, and our units, moles of S8, have canceled out. Our moles of P4S3. Okay, so if we put in 100 grams of S8, we follow our chemical reaction, which is like a recipe book, right? If we put in 100 grams of S8, we follow our recipe, we can get back 1.04 moles of P4S3. Now let's see what happens if we put in 100 grams of P4 and follow our recipe. How much P4S3 can we get out? So we move down to a new line and put 100 grams of P4. Okay, we start our reaction. So we don't have to balance, we have to convert from grams of reactant to moles of reactant. Now our reactant is P4. So we have, remember we use want over have, we have grams of P4, we want moles of P4. So if we look on our periodic table at phosphorus, it's 30.97, so we'll round it to 31. If we do 31 times 4, because there's 4 of them in that molecule, notice we don't take into account that coefficient. We're only dealing with P4 here, only dealing with P4. So we do 31 times 4, and we get 124 grams per 1 mole. Okay, we finished off step 2, so now we'll start up step 3. Step 3, we convert from moles of reactant to moles of product. So we can cross out grams. We have moles of P4. We want moles of P4S3. Notice we did the same thing here. We kept one thing constant. So here we went from grams to moles and we kept P4 constant. We went from P4 to P4S3, we kept moles constant. It's essential that one of these things, either your units or your chemical, is kept constant when you're doing dimensional analysis. So if we look at our balanced chemical equation for our mole ratio, 8 P4, P4S3 is also 8. Okay, if we plug this into our equation, or into our calculator, okay, our moles of P4 can cancel out. So we put into our calculator 100 times 8. We're going to ignore the 1. And we're going to divide by 124 times 8. When we do this, we get 0.806, 0.81. And our units are moles of P4S3. Okay? So if we look at these, we can compare them because they have the same units. This one made less, so this is our limiting reactant. We trace it back. P4S3, or P4 produced less P4S3, therefore P4 is our limiting reactant.